then I will start with going back to what DSM used to be. And as I said, it was a utility issue from the beginning. And in those days, the utilities were mainly focused on supplying energy, and they didn't care very much about the demand side. And it was gradually discovered that the energy system had at least two sides, one supply and one demand side. And when it was discovered that you could do something on the demand side, the issue was to create what was called a level playing field, to be able to act both on supply, which was normal for utilities, they knew everything about that, but also to act on the demand side, to change the demand. Today we have moved into something that we could say the DSM is a much wider issue. It's not only about one level playing field, it's about creating several level playing fields where you're also recognizing that the energy system could have many other values. So we have already entered into something that is much bigger, and as you see on the screen here, I've taken a quote from Ontario where they, in the demand side management program, have said that they have a variety of goals, environmental, financial, health, and resilience, and they should try to balance all of them. So DSM is already today a much wider concept than it used to be, but basically the same thing applies. We have to act with the demand, not only with the supply. And one of the things that has happened during all these years, these decades, is that we today see much more information and communication technology in the system. We see new applications in the system. We are talking about smart buildings, smart devices, and we see new and smaller generation units that can also be part of the game when you are trying to apply a level playing field. So technology is expanding all the time and gives us new opportunities. Still, however, and most of us who are here today, we know that the cheapest resource is energy efficiency, as you see in the bar on the left-hand side of the slide. And all the supply options are more expensive. That is something that we are well aware of, and why is it not applied more? Some people say that, that is because of price. If price was only higher, it would drive a change for us to be more energy efficient. I took this slide out of the IEA World Energy Outlook 2015, where they have provided information about the cost of the measures in non-energy intensive industries for lighting and so on, and that is the lower line that you see on the slide. And they have also provided the dotted lines above where the price level for that category of customer is. And as you can see, the difference between the measure for non-energy intensive industries up to the price level that they are facing is 8 times. And if you look on lighting, for instance, it's 16 times. So yes, of course, if prices were higher, it would create more of an incentive. But I still think that a difference of 8 to 16 times is very much an incentive enough. So I don't think that the idea that prices should be higher would drive very much of a change. And also from the works of the IEA, and this is from both the World Energy Outlook 2015 and the Energy Efficiency Market Report this year, shows, for instance, that 2/3 of the economic potential to improve energy efficiency remains untapped in the period up to 2035. So even 20 years from today, the potential that we have already recognized will not be used. It will not be realized. So we certainly have a problem. Maybe we should quote the old Apollo 13. They said, Houston, we have a problem. And energy efficiency community, we have a problem. DSM used to be the idea that we could plan and implement activities that were directed to influence customers, and that would require that we develop management functions for planning, evaluation, implementation, and monitoring. That is still valid, and that is still something that we are struggling with and what we have to do. But because energy efficiency is poorly recognized on the market, I think we should add for the future that DSM has to be large-scale deployment of energy-efficient equipment by use of specially designed programs, and that we should think in terms of massive deployment of energy efficiency. We have to gear up for doing that. And it's interesting to see that the World Energy Outlook that is produced by the IEA, they issued their latest version today, 2016, and there is a chapter 7 which you should study a bit, where they are giving examples about energy efficient motor systems, and they are saying that, or they are giving examples on how a large scale deployment could be politically incentivized. So my first message, or my first reading out of the situation we have been in since DSM started and up till today, is that energy efficiency is poorly recognized, and we have to focus much more on the deployment. Now the DSM University, we have arranged the material we have in 6 themes, and the first theme is the logic of DSM. Is the logic still there, or has the logic changed? In one respect, it's still there, and if we think about how the energy system works, we take primary energy, we convert the energy, we distribute it, we get final energy, send it out in the grids, and it finally ends up with the customer as an energy service. We are still very much talking about what happens in the system in terms that is applicable for the energy providers, the energy suppliers, the utilities. We are talking about their corporate decisions, which are based on their economic thinking, because it's a company decision, but we disregard that the application require individual decisions, and the individuals, they are not thinking in terms of economy primarily, they are thinking about usefulness and comfort, and we will come back to that. But my basic message here is that we are still talking about energy efficiency with the language that companies are using, and we are not talking about it in the language that the users, the demand side, is using. The overall logic is very much there, and this is a picture taken from the World Energy Outlook from the IEA 2012, where they, as usual, they make current policy scenarios, say where are we heading, what will happen if nothing happens, business as usual. They are trying to find out what happens if all the political decisions taken in the world really have the impact that they are supposed to have. And that is a blue line, that is what's coming up. And finally, they make a view about what is required, and that is what they call the 450 scenario. And that is basically the idea that we should keep the 2 degrees warming in the climate change. And in 2012, they made another calculation. They also tried to find out what is profitable and what would be profitable in the regard of the customer, the users. And they found out that just by applying what is profitable for the user, we should almost come all the way down to the 450 scenario. So that is a way of saying that energy efficiency is very important. And since then, the IEA has followed up with that. And they have produced energy efficiency market reports every year since. And they have gradually sharpened their message. In 2013, they said energy efficiency is the first fuel. And you know that this has been widely accepted today. The year after, they said efficiency is an invisible powerhouse. and to be followed by efficiency is a hidden jewel. And this year, 2016, they said efficiency is one resource all possess in abundance. So the IEA have sent a very, very strong message about the need for energy efficiency, and they have also underpinned that message by studying what is known as the multiple benefits, and we will come back to that a little bit later. In parallel, we have seen, and we are now entering with full force, I would say, into the fourth industrial revolution, and all the industrial revolutions since the first one in the 18th century has been very much about how we are using energy more wisely, and it is improving all the time. But now when we are entering the fourth stage, the fourth industrial revolution, we will see amazing new energy concepts also for energy efficiency. So to continue with the logic here, we could say that technology provides expanding possibilities, and it will grow even further. That we have an institutional and political awareness that allows DSM to be an active tool for efficient use of resources, and we are also now looking into, or we are facing, or we are entering into when people are talking about circular and sharing economy, and that will also have an impact on energy efficiency. Behavioral issues will get a more pronounced role, and that is because we have also understood gradually that technology will not solve it all. It's very much an issue about how we are using the technology, for what purpose, and what technology does for us. And we also see that we are now starting to talk about sufficiency, not only about efficiency, but sufficiency. And one way to sum this up is also to think about what the Danish professor Jørgen Nørgaard said a few years ago when he said that if we are just making economic calculations, they might lead us wrong. I think he said something like, it might not be cost efficient to save the world, but it could be a good idea anyway. Second theme is about the governance. How should we govern? How should we change? How should we promote energy efficiency? And first of all, I would like us all to remember that if we want to change the market and we look on the market, it can always be portrayed as following a normal distribution. We have a base case with a few rather bad products on the market. We have a majority that is quite good, and we have a minority that is extremely good. And if we want to change that normal distribution, we could change it from the blue curve to the purple, from the base case to the preferred case. But we have to do it keeping in mind that there are three ways of doing it. That is, one is to get away of the worst product, the worst available technology, here called the WAT, to promote the best available technology, and then try to find out if best available technology could be made even better, here called BAT+. But if we really want to have a change on the market, we have to apply all of them. And sometimes you hear people advocating that we should do just one of them. We have to do more research for new products. Fine, we have to do that, but we should not forget that we have to get rid of the worst ones at the same time. The multiple benefits is a very important part of the governance, to recognize the multiple benefits. We are very much talking about energy as savings, and it's a win-win. If we have more energy efficient products, it's an economic win, and that is always where we start the discussion. But this palette from the IEA multiple benefit studies shows that energy security, industrial productivity, climate change also benefits from energy efficiency. And that has been gradually recognized and is now a part of the DSM package, so to say. But we further have to recognize that there are many other benefits that can be recognized and taken into account. Then, admittedly, that is not an easy calculation. That is something that we have to work upon. We further have to take into account that a lot of the economic calculations presented trying to show if energy efficiency is economically efficient or not are made as static analysis, and we face that many say, the economists say that there's a trade-off between, on one hand, increasing energy efficiency, and on the other hand, the economic efficiency. And admittedly, not everything that can be done technically is necessarily economical. But I think it's important, and I'm trying here to show with 5 arrows, that technology is improving through market learning. We see it in the learning curves, and we all know that, for instance, photovoltaics has been much cheaper because of the market deployment, and that also goes for a lot of the energy efficient equipment. That we see new technologies coming along at a very, very high speed, that we could take multiple benefits into account, not only making the simplistic rational energy economy calculation, but also take into account the value of the multiple benefits. That policies need to be approved, and we are now talking also about behavioral economy and so-called nudges as ways of trying to refocus the market and the people and the customers and the users to the advantages of energy efficiency. And finally, the 5th item, please keep in mind that energy efficiency has a systems perspective. It's not only about changing one sort of equipment to some other sort of equipment or to just a more efficient piece of equipment. You will see that in the World Energy Outlook that I mentioned earlier today in the chapter about motors, where they show that it is not only about shifting one motor to another motor, but it's a system where the motor is operating that needs to be changed. And next item, then, we also have to take into account how real people think. And this is a little bit busy figure. It's taken out of World Bank publication from last year called Mind, Society and Behavior, where they showed that, first of all, the way we all think, not only say people think, but all of us, we are also people. We are not consistent in our thinking. We have an automatic way of thinking, and we have a slow, deliberative way of thinking. And some of you recognize that this is taken out of the Daniel Kahneman's work and the book that he has written called Thinking Fast and Slow, which I highly recommend because it gives new insight to how people are thinking and how we can advocate energy efficiency in talking about it and marketing energy efficiency. Second issue is even if we are applying the right thinking, we are also governed by beliefs and habits. We are governed by listening to people that we trust, and we distrust other people, and just the recent events in the American election gives you abundant proof on that. The third item is that there is a public domain for our thinking, that even if we have got everything right, we are also governed by what people around us are doing. Is it socially acceptable to make a change, or is it not? A very striking example of that is to look at what people do have photovoltaics on their roof, and the easy answer to that is that the people who have photovoltaics are the people whose neighbors have photovoltaics. So what is socially acceptable, what is known in your surroundings, has a great impact on the way you are thinking and the way you are acting, what you are doing. And finally, some of the information that we are having, we are just filtering it out for those reasons already mentioned. But to conclude that part, governance requires more attention to real people. What are real people really doing? We have to leave the domain of only thinking in terms of the technology. But going back to the technology, what was originally set out in the DSM is still highly valid. It's still an issue about the load level. Should we make a strategic saving, or should we have a strategic growth, or should we have them both simultaneously? And the answer is probably, yes, we may have to have them both. We want to go from a carbon fat to a carbon lean system. So the old message about shifting the load level is still very much in the center of the DSM. We have to make an assessment of the least cost delivery, and sometimes we have to also keeping in mind that we should do that in the IDSM way, the integrated DSM, taking also the supply side into account, and we will. I will come back to that. But when we are doing it, we should also think about that some of the technology provided to us, which is called smart, is not always that smart. This picture, this slide is taking out of a work where they have tried to compare 27 smart lamps and found out that some of them had higher energy use in the standby mode than in the active mode. So, and smart is not always that smart. But load level changes is still the main focus. That remains very much so. The other issue is the load shape. And load shape is also very much as it was basically described in the DSM works, and that had to do with shaving the peaks, filling the valleys, and maybe shift between peak and valley. The only thing that has changed today is that we have many more opportunities and many more opportunities coming up. First of all, we would like to fill the valleys, for instance, by charging electric cars during nighttime, for instance, when electricity is cheaper. But we also see battery technology is coming in at a growing speed. When we are shaving the peaks, it's not only about shaving, but applying, for instance, local resources, like in this example here, putting photovoltaics on the roof. So the technology gives us many more opportunities to shift between the peak and the valley. Sometimes it's argued that we should do that because it's economically good for us, but for many of the customers, it's very small amounts that they can earn from this shifting. But still, of course, for big customers, it could be much more useful. From a systems perspective, we can see that changing the load shape will have a lot of important and economically important outcomes. We may have to keep somewhere in the back of our mind that these new technologies, they will also change the markets, and that the market design is an issue that is very much talked about in many countries today. In the system we have today, when we are ranging from the cheapest resource hydropower to the thermal power to the gas turbines and see where demand is clearing and giving a price for the system, that is changing today already dramatically. And if you look at the lower left, right-hand corner, you see that PV and wind is a very cheap resource that pulls the price down. And if we then also change the demand, we make demand more elastic and we move the demand, that will further press the prices down. And there will be a lot of discussions about DSM perspective when it comes to the market design. But load shape shape changes will be important, but they will also become more strategic. They will be part of strategic discussions about how the entire system will be affected, what it does to the price, and if the price will be sufficient, for instance, to give incentives for new supply and distributed generation. Moving into the fifth theme, it's about integration, how we put all this together, and we have already mentioned that technology is changing. You have already seen these pictures, several of you, and we will not dwell on them anymore, except saying that it is a more complicated system in the future, but also a system that gives us so many more exciting opportunities and makes DSM even more thrilling than it used to be in the old days. If we just want to give it a very simple explanation, we could look at how we can go from the present system in the left-hand corner up to the sustainable system in 2 steps. One is to be applying, moving from a low efficiency system to a high efficiency use of energy as step number 1, and in the second step choose a different supply from a high density supply with fossil and nuclear to a low density supply with solar, wind and bio, for instance. And these 2 steps will have to be taken maybe not together, but in this sequence, first 1 and then 2, to finally make us end up with a sustainable system. The twin-step approach, so to say. So integration takes a more holistic view and gives, gives holistic a real meaning. The final theme we are using when we are analyzing DSM in the IEA DSM implementing agreement is about the business models. And the business models will have to change, and they are changing. First of all, we have to think in terms of how service is looked upon on the market and by whom. We, and that is us, talking about energy efficiency, marketing energy efficiency on, we are focused on products and we are talking about products and we are thinking about the boxes, which is square meters, the carbon dioxide is the kilowatt hours. But they, the customers that we are trying to approach, whose demand we are trying to change, they are thinking in terms of service. In this figure, they are thinking, is this green? Does it make me happy? Is this for the future? Does it provide comfort? And sometimes we use the expression that we are using unique selling proposition, the USP, and everybody, every one of you who has been participating in sales training, you have heard the USP, that you should describe your product to the customer so the customer understands that this is a good product. But it might be more useful to think in terms of UBR, unique buying reason. What appeals to the customer? What is the customer interested in? So when we are changing business, we have to turn from thinking and talking about products and start to thinking in terms of service. And this service will also have values for the customer. Here I've taken a picture out of a presentation made in this DSM University about multiple benefits made by Catherine Cormans, where she had tried to show that the cost implication that we normally start with, the lower energy cost, we might want to put in more arguments, for instance, about lower maintenance cost, and this is the case for a sewage pumping station, and that the pumping capacity increased, and that has an economic value that affects the costs. But it also has a value proposition because the new pumping station, that it had better service quality, it gave less noise for residents, It had a higher customer and employee loyalty consequence, so it had a value. And it also had a value in terms of risk because it had a lower flooding risk, it had a lower breakdown risk, it had a lower legal risk. And I've tried to show them here by putting a plus in the arrows and say that all these things together, they have values. And it doesn't only have a cost implication, but we are normally quite untrained in discussing and presenting the value. We are focusing on the cost only. So when we are talking about the business models and when we are trying to shape the new business model, we have to think about DSM, that it is about service and value and less about cost or convenience or any system, because for the customer, in the end, they are only judging us from the perspective that is it useful for them. So, having gone through these items, I've also put it in a paper that can be downloaded from the website where you entered, and it will be put up after this presentation. You will get a small summary of it all. I would like to finish off by first of all saying that I think that sustainable growth is possible only if we have DSM and global cooperation. Here I phrased it as a question, and I hope that you unanimously say that when I ask, is sustainable growth possible without DSM and without global cooperation, you would say absolutely not. Second thing I would like to remind you of, and I've taken this from a South African cartoonist called Zapiro, and several of you may have seen his works many times before. He has taken this from a conference where they have all the translators sitting in boxes translating from one language to another language. But here the organizer, they thought that they need another translator that they were missing. And that was a translator that should turn rhetoric into action. And who are these translators? And I frankly think it's you who are listening to me now. It's you who should do this translation. And by that, I would like to finish off. Thank you.